Good evening, dear viewers. Today I'm gonna work on some refactoring, and why I decided to do some refactoring, because I've noticed that it's a little bit hard to test the frames parsing, and probably it makes sense to simplify a little bit the structure, because right now in my uncompressed packet reader I use too much of dependencies that actually kind of unrelated from each other. So after I moved the logic of the packet splitting outside of the read buffer, it doesn't make sense anymore for me from point of view of the implementation here. If you take a look here, for instance, read fixed integer, it takes data from the read buffer and invokes a read method on top of this read buffer. And the same happens with the fixed string, the same happens with a length encoded string as well, the same happens with null terminated string. It heavily uses just read buffer, and as well read rest of packet string. The same thing happens here as well. It just uses read buffer. And here, for instance, I don't use any of that stuff, and it just doesn't make sense to use it, because yeah, it's just goes more closer, like read buffer must be part of a separate implementation that is not a part of the packet reader itself. So it does make sense to create a buffer payload reader that uses buffer in order to read the data of the payload. And we're gonna move into this implementation. We're gonna move this read fixed integer, length encoded integer, and other methods. So what I'm gonna do now, I'm just gonna create various test cases for the simplified buffer payload reader that would encapsulate inside of it the logic of appending data into the buffer, and as well we'll use the buffer itself to read data from it related to let's say fixed reading fixed integer, reading length encoded integer, and other stuff. So let's go into the test case that I've just created. So first of all, I'm gonna start with just creating an instance of this buffer payload reader. I'll have it defined here as a full class name, and I can right away create this class inside of src, so it will be just an empty class. So it's gonna be buffer payload reader. Okay. We're gonna create this instance, and probably I can create I can just invoke some static methods that will create this instance. Okay, now I'm gonna think about how I'm gonna implement it. So shall I create a factory for this one or not? It's a big question, but I think it definitely doesn't make sense, because I'm just gonna have this simple factory method on the class itself for now. Later on I might decide to move it. Actually, let's move it right away. Let's keep it in the same structure as it happens with the normal packet reader factory, because this one already, you see, it's instantiates the classes directly, and we might want to do the same for our case. So let's see, what did I wanted to do? I wanted actually to go with the buffer payload reader, and here I wanted to use a factory of this payload reader itself, and I'm just gonna use here actually I don't need this one. I'm just gonna have a class. Let's keep it simple, let's not overcomplicate it, and I will also pass here as an argument read buffer. So buffer payload reader, it will receive a read buffer, and this one is going to implement our payload reader interface. So add method steps. Now we're gonna go here and actually write some constructor for this one as well. So private buffer buffer this buffer okay. Now I'm gonna create something like a test for implementation of this buffer payload reader. It's gonna have couple of ways to work with it. It's gonna have an append method into which we're just gonna append the data into the internal buffer we are using, and we're gonna also read the data from that buffer afterwards. The only thing that, let's see what actually I also need from the packet reader. I have so much append methods, it's a little bit also, it's not looking very good in my opinion, but yeah, here append method is doing different logic than the append method into the buffer. So basically our method is gonna have two similar methods that are invoked on top of the on top of our regular buffer payload reader. So there's going to be an append and there's going to be flush. So this is the only methods from the buffer that are actually needs to be used and exposed into the packet reader implementations that we have. So later on maybe we'll refactor that one as well, but for now let's keep it like this. For now I only have two interfaces here, it's packet reader and payload reader, so this is the classes that are going to be exposed as a public API of this protocol itself for reading the data from MySQL stream. And yeah, so it's gonna be a way to extend the functionality. So I think it's okay to just follow the simplest solution so far. So let's start with writing a test. Let's start with reads 1 byte reads 1 byte fixed integer, right? Here we just gonna add into this payload reader. We're just gonna append. Let's append x01, 02, and x03, and let's assert that buffer payload reader read fixed integer that is gonna read the 1 byte. Yeah, here it's gonna be, yeah, let's actually read multiple values. So here 2 and then 3, and here we're gonna as well just read data 3 times. Okay, let's run our test. Oh, okay. Okay, it tells us that called undefined method append. Yes, because I didn't define it. Let's add a method. Let's say it's some payload. Okay, for now it just fails, right? So it just returns us null values. Okay, now we're gonna go over and use our buffer, and we're gonna pad the payload inside of this buffer. It's still gonna fail in my opinion. Let's see. Yeah, it still fails. And let's just use this buffer read. Okay, so now we actually have a case where actually we need to get some dependencies that we were using before, and this dependency is actually called binary integer reader. So it looks like, yeah, we need to create a factory for our new class. So it's gonna be buffer payload reader factory, and it's gonna create for us an instance of the payload. Probably we are not gonna supply anything else. We're just gonna create an instance. And here, right, we're gonna have something like this. Oh yeah, we're gonna return new buffer payload reader itself, and here we are gonna pass as the first argument, we're gonna pass new read buffer, and we're gonna pass binary integer reader instance as well. So this is the one that we need to use to parse our integers, right? So this is it. Here it complains that I don't have it specified here in constructors, so it's gonna be integer, binary integer reader, okay. let's initialize this one. Okay, good. This one is done. Now I can actually add and replace this one here with new buffer payload factory, create an instance of the payload reader. It tells that it's still failing, so now I can go on and implement the method here, and I can just return this buffer read. Let's hardcode 1 for now, and let's write read from integer reader. Just gonna read fixed the binary of size 1. Okay, so now we have the first test passing. Let's go to the back to the test case, and let's create reads 2 by read multiple bytes of fixed integer. So in this case we're gonna add some additional data, right? So we're gonna append some more payload here. We're gonna use probably some of the data that we had already in previous test case for the packet reader itself. Let's see, do we have anything like that here? Allows reading various fixed integers. So this is the payload that we had here, and yeah, here is the data we were using before. So let's just copy this test data here. Oh, nice of you, PHP Storm. Let's pass without formatting. Okay, now it's better. And now I can just execute this assert equals, and let's see, what do we have here? Packet reader test. Yeah, so I just can copy over this one, and here, where it is, and here I'm just gonna execute read different lengths of bytes. Let's see, how can I copy over that one? Okay, so it's gonna be this one, so it's 2, 3, and 8. Okay, good. I think it's enough. So 2, 3, and 8. 2, 3, and 8. Let's see. Okay, it seems like my window got a little bit too big. Let's resize it, and let's make the size a little bit smaller, so now you probably see it better. Okay, let's it's not Mac OS X. I'm used to Control R on Mac OS that just reruns my tests, so I don't know how it's done in here. Can I somehow rerun it through this one? Oh, it's Control F5 here. Yeah, it's a little bit tough because on macOS it's much more easier. So let's see, Control F5. Oh, nice, syntax error. And syntax error because I forgot the semicolon. Let's restart our test. Yeah, we have a failure, and failure is correct because I didn't implement it properly because I was following the practice of TDD by not implementing the final functionality right away. So let's see. Now it looks good. So we have the fixed integer being covered. Now let's go into another test. Reads. Let's have a test for length encoded integer. So reads 1 byte length encoded integer. Let's resort to this one. Yeah, so here we have pretty nice payload, I think, but we can just create our test case there. I don't want to repeat this one because length encoded integer needs to be tested more thoroughly, and I'm just gonna add something like this buffer payload reader, append some data into it, and we're gonna check 0 0. So this should be 0, and then we're gonna encode another one like FA. FA is still possible or not? Let's see. DAC hex. Oh, actually, HO hex DAC. FA. I don't remember exactly. Yeah, it's 250. So FA is possible. Then what else do we have? We also have probably F9. Yeah, F9. And we're gonna have, let's do something like F0. Or actually not F0, let's choose A0. I think it's something like 10. Right? Oh, A0 is 160. Okay, almost almost correct. It's 0, A is 10, and A0 is 160. I'm good that I didn't put it in an assertion. Okay, so assert equals. Now let's put our expectations in, and the first one is gonna be 0, of course. Then it's gonna be 250, and then it's gonna be what? It's gonna be 249, and then it's gonna be 160. And here we're gonna have this read length. Oh yeah, this buffer payload reader read length encoded integer or null. Okay. This one fails probably. Yeah, because I need to first of all do it 4 times, I think. This is one thing, and another thing that it probably returns for me null right now because there is nothing returned from this method. So let's just return this read fixed integer, let's say 1 byte. Yeah, it's passing. Okay, so this case is implemented. Let's add another test case. Reads 3 byte length encoded integer. Yes, I think it's good. Reads 3 byte length encoded integer, and then we can just return this Oh, why do I return? I just need to create those 3-byte length encoded integers. Let's see, packet reader test. Okay. So that one at least needs to be starting from 251, so we can encode that value. We can use deckhex 251. It's gonna be FB, and as far as I remember, it starts with FA. So we just need to use this buffer payload reader append, and we're gonna append some data like XFA, so it indicates that it's 3-byte integer as far as I remember. Let's check right away the protocol implementation details. So basic data type, integer types, and here is we take a look at length encoded integer, so it can be either 1 byte, 3 bytes, 4 bytes, or 9 bytes. So if it's FC, okay, not FA, okay, FC plus 2 bytes. Okay, let's do FC, and 2 bytes is, so if it's greater or equal to 251, so let's start with 251. It's gonna be XFB X00. So this is how we indicate that it is little endian type of fixed integer. Then we have XFC, and then we can specify that in this case it is gonna be 252. Yeah, let's do 52. So it's gonna be FC again and 00, and let's add something bigger. Let's add also XFC, and we're gonna indicate here that it's gonna be F. So it's gonna be 255, and the upper bytes are gonna be, let's say, F0. Let's see what number it is. I don't know exactly. I'm not good at this kind of binary things. So let's see, F0. Okay, so it's 61,695. Okay, this is good. Now we can just add here this assert equals, and here we're gonna specify the values as we specified them. So the first one is 251, then it's gonna be 252. Okay, and here it's gonna be 251, 252, and here Oh yeah, so it's only 3 integers. So now we're gonna add this buffer payload reader, read the length encoded integer 3 times. Yeah, it's here, and it's probably doesn't match the expected value. Yes, so the first ones, as you see, they are completely read wrong because we ignore here what kind of an integer it is. So here we're gonna indicate first byte, and we're gonna just return the first byte. But here, for instance, we're gonna say if first byte, let's say below 251, then we just return this first byte, right? Then our test case will still fail. Okay, here it tells 0. Interesting. Oh yeah, because I didn't read the rest of the data. And then we're gonna return here this read fixed integer. So here we're gonna read by default 2. Yeah, so now it just passes. And we can go on and work on other stuff. So let's create another test case. Let's navigate to it. Yeah, it's Control-Shift-A, I think. Yeah, now we're gonna create one for how many bytes? For 3 byte integer. Okay. Reads 3 byte length encoded integer. Reads 1 byte. Oh, actually, it's not this 3 byte, it's 2 byte length encoded integer. And now we're gonna create a new test case with reads 3 byte length encoded integer. Okay, this sounds good. Now let's write a test. So this buffer payload reader, we're gonna append some data into it. We're gonna specify that this time it's a 3 byte length encoded integer, so it should have fd, not fc, in front of it. So let's specify the xfd. Let's start with ff x f0 and 00. So this is our 3 byte integer, and let's also add another one here. Yeah, so let's see what actually this one gonna look like. So if we add just it's actually the same number, it's 61, but encoded as 3 bytes. Yeah, let's just create a cert equals, and here we're gonna add something like this buffer payload reader read length encoded integer. This one actually gonna not fail. Okay, because I hard-coded the number too, so it doesn't check for correct type. And now let's also add another one, and let's add something probably bigger. Let's specify something like f0 ff a9. Let's do like this. So this is gonna be our other number. It's gonna be starting with FF. Oh, is it correct? No, it's not correct. It should start with A9. Then it's gonna have FF, and then it's gonna have XF F0. Right, so now it's looks better, and it's gonna be this 3-byte integer number. Let's see. Yeah, the value is not returned because first of all I didn't invoke this method. So now it's finally failing, right? So that is failing with the right failure. So let's quickly just fix it. Let's just add here a number, like if first byte equals x0 xf c, then it's 2 bytes. Correct. And here, let's say we just, otherwise we'll return 3 bytes, right? Okay, so now it's passing again. Control-Shift-T. Let's switch back to another test case. And now let's create another test case for reads how many 8 bytes now, right? Reads 8-byte integer, so reads 8-byte length encoded integer, and here we're gonna just copy paste stuff. Let's start with this big number we had before, and here we just gonna replace this one, and this one should be FE now, right? And here we just can populate it with FF. Oh, actually 0 0 0 0 0 0. It's gonna be 3 4 5 6 bytes. Okay, we need 2 more. And now we're gonna also add something big as well. So let's add here another XFE, and this time it's gonna be X. Let's put something like this one, FF OA. This is how much? 1 2 3 4, and let's add FF, and then let's add CA E A 09 and FF. Okay, a little bit too big, I think. Okay, 1 2 3 4 5 6 7 8. Okay, FF was a little bit redundant. Okay. Oh, still too big. Okay, let's see. Can I just specify something like 0 0 here? Okay, can I just specify then A? Okay, this one looks better. So let's encode this value. So it starts with 0, 9, then it goes XEA, then it goes XCA, then it goes XFF, then it goes X0A, then it goes XFF, then it goes FF, and then it goes X0A. So this is our second 8-byte integer, and this is gonna be this value, just some random 8-byte integer. Okay, we know that, yeah, this one is it, but it's not parsed correctly. And we're just gonna check that if first byte equals 0xfb, oh sorry, f abcfd, then it's gonna be our read 3 bytes. And here we're just gonna return this read fixed integer of 8 bytes. Otherwise, okay, now it's passing. Okay, good. Let's see. Let's see. Let's continue. And now we're gonna go on and create another test case, because the name of the method called read length encoded integer or null. So we're just gonna add another test case here. Reads null value from length encoded integer spec. Okay, here we're gonna provide this value in the same way as it was provided in packet reader. We were implementing it before. So FB is identification that it's a null, that it's an empty, that it's invalid, that it's actually null, sorry. So let's go over here and let's add this one here. Let's add this buffer payload reader, append, and we're gonna add this xfb, and we're gonna evaluate that this assert equals null of this buffer payload reader read length encoded integer. Okay. Okay. Actually, I think I'm a little bit messed up with this one. I just realized, yeah, there is a lot of methods on the buffer that are redundant in our case. Yeah, but yeah, let's complete making those tests green. So okay, rate length encoded integer or no. Okay, so if it's xfb, it tries to read more, but it can't. So let's add a case for this one. If first byte equals x 0xfb, then we return null. So it's an indication that it's a null value. Then what else do we need to do? We need also, oh, actually, let's replace this one with inherit doc, because I don't want to edit the documentation for this method specification everywhere. So let's just inherit documentation here. Okay, now let's switch over into our test case. And here let's add another one. Reports incorrect length encoded integer given first byte is out of bounds. Okay, incorrect length encoded integer. So here we're just gonna take this buffer payload append, and here we're just gonna use this buffer payload reader, read length encoded integer or null, and before it we're just gonna expect that this expects exception. Yeah, so out of bounds it's FF because it's 255. It's unexpected value. And here we also have the packet reader test case that tests the same issue. So if we specify FF, and here we just throw invalid binary data exception class. Let's see, it doesn't fail. So let's now put this stuff here. Private const length markers. So we know that, for instance, the length marker for xfc, it's a 2-byte integer. We know that the length marker for xfd is 3 bytes, and we know that the length marker for xfe is 8 bytes. And here we can then replace this piece of code with read fixed integer from this from the value of self length markers of the first byte. Okay, it tells us that there is undefined offset 252, but the rest of the tests probably pass. Yeah, only this one that should throw an exception doesn't pass. And if yeah, let's just add this kind of a check. So we return a value every time we have yeah, let's do something like this. Let's put here a check that it is set. If is set, then we return back this value. Otherwise, we just gonna, oh yeah, I didn't return it. Otherwise, we just gonna throw new invalid binary data exception, and now our tests pass. So good, so far so good. Let's put here as well, let's move this one into the constant as well, and constant will be a null marker. Let's also make it a private const. We don't want to expose this one into the outside world. We just want to use it internally in our code base. So with the first byte is a null marker, then we return null. Otherwise, if the length markers exist, we return value with this length marker. Otherwise, we just throw invalid binary data exception. Good. This looks like a valid implementation. Now we're gonna go over and implement the rest of the things, right? Buffer payload reader. That's quite good. Okay, so now we have another stuff that we have to implement. We have to implement the length encoded string and the fixed string. So let's start with the fixed string. Yeah, the fixed string, I think it's the easiest test ever. Reads fixed length string. So just this buffer payload reader append. We append something like -x. So let's read data in buffer. Oh, actually, I wanted to refactor this one because I made a mistake by using this append method, because this reader, it shouldn't know about the way how I append the data into the buffer and so on. It just needs to work with the buffer in order to read the data. So let's do a little bit different thing. We're just gonna pass a buffer here as an argument, and we're gonna create this buffer. And here actually we're gonna replace it with payload reader factory. we're just gonna have a factory itself, and we're gonna instantiate our reader inside of our test case. It's gonna be a little bit easier to work this way. And here the buffer itself is gonna be instantiated in the setup. This buffer append. This buffer equals new read buffer. And here I'm just gonna use buffer append instead of this buffer payload reader append. In every single test. And the buffer itself is going to be an instance of read buffer. And here, where I'm actually grabbing the data, I'm gonna put here something like buffer. Yeah, I'm just gonna create a new instance here. Probably payload reader, this payload reader factory. Actually, yeah, I probably even have to move this one into a new method. Yeah, let's just create this method. We'll call it create payload reader. It will receive as an argument binary. It will receive as an argument payload, and here we're gonna use this. Actually, we're gonna just create an instance of a buffer right away, and we're gonna use this payload reader factory, and we're gonna create a new instance with a buffer, and inside of this buffer we're just gonna append the data, our payload, and we're gonna return back this payload reader instance. So in such a way, we can just replace all of the calls like this into this, and we can say it's payload reader. Okay, replace all. All is replaced, and now I can just replace this calls with payload reader itself. Okay, did it work? Incomplete buffer exception. Why? I didn't append something into the buffer. So read buffer. Oh yeah, because the buffer is added here as an argument. Here, like this. Okay, now it's not failing. Now it's properly passed. Okay. So this one is working. We can move this private method somewhere. To the end of the class. Why? It's a little bit complicated. Okay, now it's here. So yeah, now the test looks much better, and now we actually can remove some methods, like for instance append. Append I'm not gonna use, right? So yeah, this one is done. Now we have to go on and implement this readfix string. So now it's gonna be a little bit easier than before. And now we're just gonna implement and specify that we're gonna read fixed reads fixed length string. Reads actually, yeah, just fixed length string, and let's just say that okay, payload reader of this create payload reader -x, no, not -x, just 1, 2, 3, and let's just read this this assert equals an array of data that we're gonna read, and it's gonna be 1. Actually, let's make it single quotes because there is no binary data inside of it, so let's do it 1, 2, and 3. Okay, now we're gonna add a retrieval of the values. This, oh, not this, just payload reader read fixed string, read fixed string of 3 bytes, then another 3 bytes, and then 4 bytes. Yeah. Now we have this buffer payload reader. Okay, now we're gonna return this buffer read a required length of the data. Let's see what's failing. Let's see, packet reader. Oh, it actually should be 5, not 4. Okay, now it's correct. 1, 2, 3. Okay, this data is red. Reads fixed length string. Yeah, let's specify the correct variable name. Okay, now we're gonna go on and implement reads length encoded string. And yeah, let's create a payload. And let's create a payload of, let's start with simple 0, 1 and then specify something like a. Then we have another string that will be 0, 3, and then it's gonna be 1, and then it's gonna be x 0, 5, and it's gonna be 3, and then we're gonna have x. Yeah, let's keep 1 byte reader for now. And we just gonna assert read length encoded string. This is good. Length encoded string, or no, okay, it's length encoded string. And here we don't send any arguments. We just expect that it's gonna read first a, then it's gonna read 1, and then it's gonna read 3. So let's see. Return value is not correct because, yeah, let's return an empty string. Okay, the empty string is not what we expect. So now we're just gonna read this buffer, read, and then we're gonna read this read fixed integer of 1 byte, and our test gonna pass. So as you see, we just see that it has a length encoded string is something that is passed as an argument here. So let's go further on and let's implement much more longer string reader. So spec reads long length encoded string, and in this case I'm just gonna specify that, let's say there's gonna be this buffer. Let's specify a string of 1000 characters, right? I think it's more than enough. And if I want to encode 1000, it's gonna be, oh yeah, 03E8. Okay, so we just gonna this create a payload reader with XE8, but we start with XF. It was D as far as I remember. Yeah, so it was D for 2 bytes. No, it's for 3 bytes, and FC for 2 byte integer. Okay, so it should be FC, and then it's gonna be X03. And now I'm just gonna have this payload reader instance, and here I'm actually gonna add string repeat of a by 1000 characters. So we just have a very long string. So let's just validate that it equals to this value. String repeat a multiplier 1000. And here we're just gonna assert that payload reader read length encoded string or null equals to this length of a, and we see that it actually fails to read the string because actual string is much more shorter than the one we expected to receive. Okay, so let's fix that one and let's read length encoded integer or null. Okay, now it's passing, the test is fixed. But also we need to make sure that we can also read a null string value. So reads null string value. And let's see, payload reader, this create payload reader of xfb as far as I remember. And then we need to assert that it equals null when we try to read a string, read length encoded string or null. And now it fails because it must be a type of integer passed into the read method of our buffer. So let's just fix it. So here we're gonna extract a variable of the length, and here we're gonna check if length equals null. Then we're gonna return null. Good? Good. I think it's very good. So now we have a length encoded string being properly read, and now let's take a look at the packet reader. Reads fixed length string, yes. Length encoded, yes. Multiple null terminated strings. Okay, so here's our null terminated strings. Let's add the test case for this one as well. And let's read, yeah, let's add data. Yeah, let's add a test. Reads null terminated string and payload reader, this create payload reader of xf. X, there's no x. No terminated string, and it's gonna be this one, and we just will add some other data in end, just so it should just ignore that one. So let's assert equals null terminated string, this payload reader read null terminated string. Okay, it fails. Let's make it not fail. Let's just return null terminated string. So this is the first test case. We just faked its implementation. Yes, here it is. Oh no, not that one. And now let's add another one. Reads multiple null terminated strings. So let's see another one, x0, another null terminated string. Yeah, I think it's more than enough. And here we're just gonna add one null terminated string, and then we're gonna add another null terminated string. So first it reads the first null terminated string, and then it's gonna read the second null terminated string. So now we have to specify this another null terminated string here. Okay, now it's not equal to the right value, because right now we have hard-coded the null terminated string implementation. And here I'm just gonna now find this null position, this buffer scan for x null. And here we're just gonna return this buffer read till this null position. Does it find it? Oh yeah. And we also probably need to, yeah, so string is here, and we also need to move the buffer by 1, and we need to return back this string. Okay, good. Okay, now it's working well. So read null position -1. And now we're gonna go over this one, and now we also need to create another test case that it throws incomplete buffer exception when null character is not present. So it means that we still wait for some data in buffer in order to find the null terminated string. So let's see, payload reader, and here we're gonna create this create payload reader with some string without null character. All right. And here we just gonna expect that this expect exception incomplete buffer exception class, and here we're just gonna invoke this payload reader, read null terminated string, and now it doesn't throw an exception, so it's not implemented yet. And how do we check that there is a null position string there? we check that null position equals -1. Then we can throw new incomplete buffer exception. Okay, now our test fails. And we can go over and implement another one. Now we need to implement a method that will read the rest of the buffer. So this is the reason why actually I created this method create payload reader, because I don't know what is the string len of the payload by default, and I want to create this payload reader for every single packet I'm gonna read. So let's see. So throws incomplete buffer exception when null character is not present. Okay, this one I think. Yeah, it's okay. So it reads string till end of the buffer. So this is a simple case. We're just gonna create this payload reader, and we're gonna just use something like this. Create a payload reader. Some string till end of buffer. Okay, and here I'm gonna assert that some string till end of buffer is gonna be supplied here like that. So let's see, some string till end of so yeah, this is the one. So some string till end of buffer, and then I'm just gonna specify that it's gonna be returned by this payload reader read rest of packet string. Okay, it doesn't return the right value. Because I didn't specify a return value here. Let's just return an empty string. Okay, here we're gonna specify now a string len of this payload in the argument to the create method. So this packet length, and here we're gonna specify it too. So it's gonna be our packet length variable passed inside of this buffer payload reader. So this is it. And now we're gonna also add it here into one of the class arguments. And now we can use this one here. Then we have rest of packet string. It's gonna take the buffer and it's gonna read this packet length variable. So okay, now our test is green. Now we're gonna create another test case, because in our packet reader, as you remember, we have this functionality that we can read multiple packets as string with multiple payloads. So we can read multiple packets that represent a complete string till end of the packet. So I want to make sure that we have the same possibility here as well. So I'm gonna add this one here too. So we're gonna take read rest of packet string, and we're gonna create another test case here. Reads multiple strings that represent complete packet. Okay, now we have do something like this. We're gonna create a new payload reader, but this time we're gonna specify here that we have, for instance, something like packet 1, packet 2, packet 3, and last packet. So this is going to be the last string. It's going to be a length of 11. This is going to be a length of 7. And here I'm going to specify as an argument, I'm going to specify the length of the data, and it's going to be 7, 7, 7, and 11. Going to be payload length. And here actually what I'm gonna do, I'm just gonna specify it like this, and I'm gonna use I think it's int like this, yeah, int payload length, or actually packet length. And here I'm just gonna specify packet length equal packet length, otherwise it's gonna be string, an array of string len of payload. So as you see, I just did something interesting with this ternary operation. Then I just pass here an array of packet lengths. Here is going to be 2, an array of packet lengths. here it's just gonna be something like this. Right, so it's gonna be int packet length. Okay, good. And I think we need to rename it into unread packet length, just to make it clear what it represents. And here, let's go here as well. We will rename it into unread packet length. Okay. Here we have unread packet length passed in, and now here we're just gonna use array shift unread packet length Why it's risky? Because test didn't perform any assertion. Wow. Oh yeah, very nice. I'm just a little bit too tired to type it in. I completely forgot about this one. So packet 1, packet 2, packet 3, and a last packet. And here we're just gonna implement this read payload reader, read rest of packet string. Okay, now it's all working correctly. So, okay, now this functionality is tested, and it seems like it's working if we pass in the packet length as an argument. Now we need to also we need to actually advance the length of reading. Okay, so let's add another test. Reads rest of packet string starting from current buffer position. So I can create now another case, like I can create something like, hey, for instance, here we're gonna have something like 1, and then rest of packet, and then this rest of packet, and then another string yeah, so it should be 1 rest of packet, and then we're gonna add here as well a string that should not be read. Okay, so I'm gonna invoke this payload reader read fixed string of 3 characters, so it should be our 1. Then I also want to specify here how much it is in characters. So this is first packet is 17 chars, and the last packet is 30 chars. So now I expect that I only should receive rest of packet string. Yeah, I actually need to receive only rest of packet, sorry. So 17 and rest of packet is 14, okay. Yeah, then it's correct. And here from the payload reader, it should read rest of packet string, and it should return me only the rest of packet, but not the other data that is stored there. And we see that our test fails because it doesn't take into account these 3 red characters. So let's just do it like this. String length is gonna be array shift, and here we also need to add buffer. Current position probably. So string len minus current position. Does it work like this? Not at all. How did I implement it in a packet reader then? Let's see. Uncompressed packet reader. Yeah, so this is the function that was doing it. Okay. So let's just copy it over. And let's see. Where is our payload reader? And instead of shift, we are gonna use this remaining packet lengths to read. And here we're gonna have buffer, and here it's gonna be packet unread packet lengths. Yeah, unread packet lengths. Now what it throws us, it tells that yeah, it cannot read everything, so it just takes current buffer position, unread packet length, current packet index. Okay. Oh yeah, because yeah, now it's correct. And now we can actually inline this method. Okay, now it all looks good. It all looks good. This functionality is kind of working. So this is, I think, is complete. So now we can, I think we can now replace the implementation that we were using before. So now, as we already have everything implemented, we can just replace what we had before in our uncompressed packet reader with this new factory. Let's first start with adding a new dependency here. So we have, right now we have binary integer reader, we have a read buffer, and we have now, I'm gonna have also buffer payload. Oh yeah, I forgot to specify here a comma, and here buffer payload factory, payload reader factory. Yes, this is our payload reader factory, and here we're just gonna specify, yes, so remaining to read lengths. Probably we should just add also another registry for this one. Yeah, let's also add private unread packet length or remaining packet length, and it's gonna be just an integer array length. Is it correct? Okay. Now here, instead of this one, we're just gonna add it here like this. Yeah, when we're refactoring, we don't remove the code, we just add a new code. This remaining packet length, this awaited packet length itself. Okay, and here, where is it used? It's used here, but yeah, we're not gonna use this here for now. Here we're gonna just do something like this, while this remaining packet length 0 read length less than read length, then we deduct this value from the read length, and we actually do array shift of both of read length and of the packet. Okay, this is done, and then If there is no more packets, we just return back. And here we are gonna do what? We're just gonna deduct from this remaining packet lengths minus the read length. Okay, this is good. And now let's see if our tests still pass. Okay, 2 few arguments passed into the constructor, yes, because I did break here in implementation. So, okay, here I'm just gonna add new buffer payload factory, reader factory. Okay, now it's all green. Okay, so we're still in green zone, so we can go over and continue refactoring our code base. Let's see. Then we have remaining packet lengths being deducted. Good. Now we gonna just replace here where we read the payload. Instead of reading something like this, we just gonna send this payload reader factory, create an instance with this read buffer and this remain packet length, and it's still green, so that's perfect. So our refactoring did work pretty well because all the tests are still green. Okay, this one looks good. Now let's remove this unread lengths from here. Also, let's remove unread lengths. Actually, let's remove this method too. Yeah, it's unused now, so we could remove it. Now everything is still green. I really like deleting code like that. Now let's remove all this method that we're implementing reading of the fixed values. Oh, now it's failed. Oh, because I forgot to remove an interface implementation. So payload reader. And yes, now we don't have that requirement too. Yeah. Alt enter, type or name to. Let's fix the name of the variable. And let's change the info on the packet. Okay, good. Let's see. Yes, good. Now we have everything in place. And looks like everything still works well. The tests are looking green. So I can tell that the refactoring worked pretty well. And now I can just commit it into repository. And what did I modify in this one? Git diff. Oh, I just modified the constructor. Git checkout, git status. Okay, buffer payload reader, default packet reader factory, handshake parser, and compressed packet reader, buffer payload reader test, packet reader test. Okay, git add src and tests, git commit. Let's specify that we refactor it some buffer here factored packet uncompressed packet reader into simpler implementation without need to use refactored and compressed packet reader into simpler implementation without need to use what? Without to be able use it to be able to use payload reader outside of packet reader. Okay. Outside of packet structure. Okay, git status. And let's push. Oh yeah. And let's push. Okay, now I'm done. Thank you very much for joining the stream, and have a nice evening, and till the next stream, bye.